Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. It's right here. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel with practice problems for exams is at smarturl.it/pass actuarial exams. These links here give you the websites where you can find information about online seminars for exams PFM, IFM, and LTAM that I teach, and also links to the places where you can purchase study manuals for exams PFM, IFM, and LTAM that I wrote. I direct the actuarial program at Illinois State University. Information about it is at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, you can find it at smarturl.it/help-ISU-actuary. This is problem number 5 from the written answer section of exam LTAM from October 2018. This was the first time this exam was offered in this form. The material used to be very comparable material used to be on exam MLC, which was offered last in spring 2018, and now this new exam replaced it. Matt, currently age 35, takes out a mortgage of $250,000 to purchase a home at a loan interest rate of 5%. This loan will be repaid with annual payments of X at the end of each year for 20 years. NED Life offers Matt a mortgage life insurance policy with a 20-year term, which will pay off the outstanding balance of the mortgage at the end of the year of his death, including the annual payment then due. This policy will have level annual net premiums to be paid at the beginning of each year that Matt is alive during the 20-year term. You are given that mortality follows the standard ultimate life table. Interest rate is 5%, which is the interest rate used in the table, so that's convenient. K is the quoted future lifetime of Matt. Part A, question A is, part 1 says, show that X is equal to 20,060 to the nearest 10. You should calculate X to the nearest 1. Part 2 of A, show that the outstanding loan balance immediately before the loan payment at time 5 is 228,280 to the nearest 10. You should calculate the value to the nearest 1. Part 3 of A, express the outstanding loan balance at the end of the year of Matt's death in terms of K and interest rate functions. Part B, question, let Z denote the present value of the death benefit at the issue date. Part 1, write down an expression for Z in terms of K and interest rate functions. Part 2, show that E of Z is equal to X over D times A 35 colon angle 20, 1 over 35, and with a 1 above 35 indicating term insurance on a 35-year-old over 20 years, minus V to the 21 times Q 35, 20Q 35. Part C, calculate the level annual net premium. Part D, explain why NED Life might expect a high lapse rate at later durations. And here's the solution. For Part A, Part 1, the mortgage loan amount is $250,000, interest rate is 5%, and the term is 20 years. Therefore, the payment is X equal to $250,000 divided by angle 20 at 5%. So approximately 20,060.6468. This is 20,060 to the nearest 10. Part A, Part 2, the outstanding loan balance immediately before the loan payment at time 5 is X A double dots angle 16 at 5%, because that's how many payments are remaining, and we include the payment that is about to arrive, so that's why it's an annuity due. And that's approximately 20,060.6468 times A double dot angle 16 at 5%, which is 228,283.30, and that's 228,280 to nearest 10. Part A, Part 3, if Matt dies in year 1, death benefit payment is made at the end of year 1, and the death benefit includes the mortgage loan payment due at that time exactly, so the death benefit equals X A double dot angle 20. In case of death in year 2, death benefit is X A double dot angle 19. In general, death benefit in year K is X A double dot angle 20 minus K minus 1. And in the last year, it's X A double dot angle 1, so it's X. So in relation to the curtailed future lifetime of Matt, death benefit paid at the end of the year of death, which is policy duration K35 plus 1, is X A double dot angle 20 minus K35 plus 1 minus 1. So X A double dot angle 20 minus K35 for K35 equal to 1, 2, and so on through 19. But then for higher values of K35, the death benefit is 0. Part B, Part 1. So Z is equal to X A double dot angle 20 minus K35 times V to the K35 plus 1, because that's when that amount is paid, for K35 equal to 0, 1, 2 through 19, and 0 otherwise. And V, of course, is 1.05 to a negative 1 in this. So I probably should have written this as 1.05 to the negative power, but it's the same thing. For part B, part 2, we note that X A double dot angle 20 minus K35 times V to the K35 plus 1, that's X times 1 minus V to the 20 minus K35 over D times V to the K35 plus 1. And that's X over D times V to the K35 plus 1 minus V to the 21. And the expected value of Z is therefore X over D times the sum from K equals 0 to 20 of the expressions that we have, because the value of Z for a specific value of K is of this form that we indicate here, but the death can happen in the first, second, and so on years. So we sum up over all years for K equal to 0 through 20. V to the K plus 1 times K P35 times Q 35 plus K minus K, sum from K equal to 0 to 20 of V to the 21 times K P35 times Q 35 plus K. And this first expression is just A 35 colon angle 20, 1 above the 35, minus V to the 21, the second expression is V to the 21 times the sum from K equals 0 to 20 K P35 times Q35 plus K. But that's simply considering deaths for all possible years of the policy, so that's just 20Q35, the second expression. For Part C, we calculate the level annual net premium as the single benefit premium divided by the actuarial present value of the unit annuity paid the same way as the premium annuity is paid. So we just calculated that single benefit premium, that's the numerator in this fraction, and then this is divided by A double dot 35 colon angle 20. Then this term insurance can be written as A 35 colon angle 20 minus 20 E35, and then 20Q35 can be written as 1 minus 20 P35. Of course, V to the 20th times 20 P35 is equal to 20 E35. So what we have here is X over D times A 35 colon angle 20 minus 20 E35 minus V to the 21 plus V times 20 E35, and the whole thing is divided by A double dot 35 colon angle 20. But then we subtracting really 20 E35 multiplied by 1 minus V, and 1 minus V is D, so we can just write it, as you see, as A35 colon equal 20 minus V to the 21 minus D times 20 E35. And then if we take that D and put it in 1 over D and put it inside, this becomes X times A35 colon angle 20 minus V to the 21 over D minus 20 E35 divided by A double dot 35 colon angle 20. And every single one of these things can be looked up now in the table. And of course D is equal to 0.05 over 1.05. So we plug in those values, do the calculation, and we obtain 104.4471231. For Part D, we note that NED Life can expect a high lapse rate at later durations because, as this policy is designed, level premiums are funding decreasing death benefit. As the mortgage loan balance becomes smaller, it makes less and less sense to pay for the life insurance. Note that the loan amount payment is about $20,060.65, while the insurance annual net premium is 104.45. So the outstanding balance of a loan will not drop below the amount of a life insurance premium. But at the beginning of the last year, the outstanding loan balance is the present value of that $20,060.65, so about $19,105.38. And the expected value of the death benefit at that point will be this multiplied by the probability of dying, and that's about 34.33. So you're paying 104.45 for something that is approximately worth 34.33. It really doesn't make sense to do it. And the policy, by theoretical standards, using the actuarial present value of future benefits minus actuarial present value of future premiums, would end up having negative reserves in late policy years, which also doesn't make any sense. It doesn't make sense at some point to keep this insurance because you're simply paying a lot for something that is worth much, much less. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.